Imagine waking up tomorrow to a notification that halts global markets and triggers emergency government sessions. The headline reads, "Artificial General Intelligence has been created." You might look at the tools we use today, like ChatGPT, Gemini, or Claude, and assume the breakthrough already happened. After all, they write code, generate videos, and pass bar exams. But underneath those impressive outputs, today's conversational models are classified as narrow AI. They predict the next logical word in a sequence based on patterns, but they lack actual comprehension. Moving to AGI requires a different approach. It means transitioning from software that mimics human outputs to a machine entity that thinks, adapts, and learns independently. To see the limits of narrow AI, look at this photograph of the 2016 DeepMind AlphaGo match. The machine on the left mastered the game of Go so thoroughly that it defeated the world champion, demonstrating absolute expertise within one strict set of rules. But if you ask that same supercomputer to perform a basic appendectomy or design a functioning rocket valve, its expertise collapses. Its intelligence is locked inside the domain of a board game. We've spent the last decade building brilliant calculators trapped inside specific boxes. The pursuit of AGI is the attempt to build a machine where the box no longer exists. As you can see in this animated diagram, a calculator operates on a rigid single input and output loop, while a human brain features interconnected nodes spanning math, art, and language. Artificial general intelligence aims to replicate that biological adaptability, creating a single system capable of reasoning through physics equations, composing music, and navigating a crowded street simultaneously. This is why simply feeding more data into current chatbots will never produce AGI. If you give a standard calculator 1,000,000 times more processing power, it computes numbers faster, but it will never spontaneously write a poem or understand the concept of grief. Crossing the gap requires new ways for machines to process information, rather than just building larger data centers. The first pillar is transfer learning, migrating a simulated game strategy to a real-world corporate problem. The second is real reasoning, building sequential cause and effect logic for unseen problems. The third is autonomy, taking an objective, designing experiments, and adapting to failures without intervention. When a single system possesses all three of these capabilities, it stops searching for existing human answers. It begins inventing original solutions from scratch. Right now, the underlying architecture of modern AI struggles to bridge these three distinct pillars, creating a significant scientific bottleneck. To break through, top research labs, including OpenAI, DeepMind, and Anthropic, are spending billions of dollars to test entirely new ways of structuring machine thought. The competition now centers on re-engineering the mechanical architecture of thought. Imagine a new coworker joining your office. On their first day, they absorb your entire field's history. By month 3, their output is 1,000 times better than your own. They never sleep, and they never forget a detail. This shift transforms the technology from a digital tool into an autonomous colleague, one capable of solving complex problems without human guidance. The potential for discovery is immense. We see an autonomous intelligence spending a single night analyzing millions of medical journals, synthesizing complex patterns invisible to human eyes, and proposing a functioning treatment for a decades-old disease by the next morning. AGI represents a point where human biological limitations, like our need for sleep or our slow reading speeds, no longer act as the bottleneck for scientific and societal progress. Because AGI relies on transfer learning, the same reasoning pillars used to map molecular biology can be pivoted toward the complexities of global economics or strategic warfare. At this scale, mastery in one domain effectively becomes mastery in every domain. This concentration of power is why a parallel global race exists today in the field of AI safety, trying to ensure these systems remain aligned with human survival. The timeline is fiercely debated, with estimates ranging from 5 to 20 years. Yet, across the board, experts agree that the arrival of AGI is inevitable. The defining question of our century is no longer whether we can build intelligent machines. The question is what kind of future we will choose to let them create. If you want to keep tracking the reality behind these breakthroughs, subscribe to Beyond AI and join us for the next episode.